Hello, in this video we will see about the basic about the analog and digital signal. First, digital data transmitted over the wired base on two ways. First one is the electromagnetic waves and second is the light pulse. Into the light pulse or the light pulse normally used into the fiber optics cable. First one indicate the electromagnetic waves and second one is the data transferring into the wired based technique with the help of the light bulbs. Normally it is into the fiber optics cable. Some of the examples about the analog and digital signaling. Earlier audio CDs are in the form of the analog data and MP3 that is in the form of zeros and one. Basically there are two types of signaling. First one is the periodic signal. It means it repeats itself after the specified interval. Means basically first is the digital periodic signal. So that is the example of the digital periodic signal. Digital data or digital signal, it is in the form of this square wave. So it has the specific or specific interval repeat after some duration. So that is called as the periodic digital signaling. This one is the periodic analog signaling because this is the example of the analog signaling and the shape after some specific interval is constant or it is same. Aperiodic signaling. Into the aperiodic signal, it is very hard to determine the pattern well in advance. And this is the example of the aperiodic signal. We cannot determine the exact shape after a specific interval or pattern. That is an example of the aperiodic digital signal and aperiodic analog signal. Now analog signaling. There are the certain use of the analog signaling. It is helpful when we have a very limited bandwidth available to transfer the data over the network. In that case, analog signaling is preferred to use because it occupies the required bandwidth for sending the data from one sender to the another receiver. There are properties of the wave. Basically three properties of the wave. First one is the amplitude. Amplitude is indicated using the maximum voltage value. So that is referred to as the amplitude from the base. This one is the amplitude of the base, means the maximum voltage value. Second is the frequency. Frequency, that is the number of oscillation per second generated. So this is the first oscillation, this one is the second oscillation, that is called as the frequency. And third one is the phase. Phase means the direction of the signal is moving at the particular period of time. So that is the direction. Down, right, that direction is the top, and right, this one is the down, right, etc. So there are the three properties of the waves. Analog signaling. Analog signaling means changing into any of the three property. It's explained amplitude, frequency or phase to indicate the digital or the analog data, that is referred to as the analog signaling, where the modulation is the technique for representing the value 0 or 1 using more or using one or more properties of the wave, that is referred to as the modulating. Frequency modulation. The definition of the frequency modulation is when the analog signaling is performed by changing the frequency is called as the frequency modulation. So frequency is the number of oscillations per generated during the period of time. It may be more or less, but there is no changing into the amplitude and the phase in that case of the frequency modulation. Into the amplitude modulation, the analog signaling is done using changing the amplitude of the wave, that is referred to as the amplitude modulation. There is no any effect into the frequency as well as the phase into the amplitude modulation. Where into the phase modulation, if the analog signal is performed using changing the phase of the wave, that is referred to as the phase modulation. In it there is no any change into the amplitude or the frequency. Second is the digital signaling. Digital signal can be represented by 0 or 1. In this example, 0 is represented into the lower part and the 1 is represented using the high voltage. So that is the example. 0 it is represented using the low voltage, then 1 it is represent the high voltage, again 2 0 are represented using the low voltage. It is used to transmit the data or digital as well as the analog signaling. So analog signaling is used for the both of the cases. If you have the analog data like audio data, or if you have some computer file format or some MP3 data which is in the form of 1 and 0, and still you want to transfer analog as well as the digital data using the digital signaling, then it is used. Some of the example of the digital signaling is that if you have some data into your computer and it is in the file, then whatever the data into the computer are stored into the form of 1 and 0. So digital data transferring using the digital signaling. Downloading a data, again downloading a file or a data from the server, the data available in the server in the form of 1 and 0. So if you want to download it, then the digital data transmitting using the digital signaling. Suppose I have a login account for any bank website. So when I send the detail like username and password, then its equivalent ASCII value are entered, then it will be converted into its equivalent binary value internally. So again that is the digital transmission, digital data transmission using the digital signaling. And sometimes we can also transfer the analog data using the digital signaling. Say for example voice, what we are speaking right now on a telephone system or such type of system, that is in the form of the voice, means the analog data, and further it will convert the analog data into the digital data using the digital signaling. And those are the formula to calculate the bit rate. There are some of the characteristics of the digital signal. Very first one is that it generates this square waveform. Here in the figure it is the example. Digital signal generate the form of the square form. Second is that it has a very limited values to represent it, that is the 0 and 1 voltage level. Third characteristic is that sometimes it is difficult for the receiver to identify the exact value. Say for example the sensitivity of the receiver. Suppose I send a data using the 1 voltage, but due to the error into the communication channel, it is converted from 1 to 1.5. So it will become for the receiver to consider it either 1 voltage or 2 voltage. If he or she consider as a 2 voltage, then it will create a problem. And last characteristics is digital device require a repeater after a specific distance. So if we are transferring the data from one sender to the another receiver using the digital signaling, in that case we use the repeater to transfer the digital data over a long distance, because after specific interval there will be chances of into the data communication about the data corruption or the data loss. So this is the digital data with the error. So we have to use the repeater for the digital device into the digital signaling to remove the noise from this data, and again it generate the original one. In the analog device there is the amplifier which convert the error data into the again proper form, but into the repeater will reshape and repress the data, means we can convert the error data into the proper data. It is possible in repeater, but into the amplification process the error is again strengthened or noise is again strengthened into the amplification process. So again the error is always there. Thank you.